Okay, before I wasn't very careful when I substituted into the quadratic formula. I put my 4 here and my 6 here. Okay. Oh no. I left my -4 there. If I'm going to change my numbers a little bit, it should be -6, -6. So that's going to shift these points by about a half. It'll be a half in the negative direction. Oh, darn it. Okay, thinking that's going to be 1.5. Or -3.5 3/4. Okay, that works. That's going to be 1.5, -3.5. I'm not going to relabel these. 3.5.
My own card, I didn't put my own money, so now it would be so much better. All right, so I'll show you the work. It's not that hard.
0. $1.50. I'll stick with this estimate, which isn't very good. I'm going to stick with it. It's going to be less than that. It's going to be less than 1. Okay. So, again, correcting what I did with the quadratic formula changes my numbers here a little bit. Doesn't change the -15. And if this is 1.5, that's still plausible. Those points aren't too badly located. So we get these estimates. Now, with all that, again, we have the principle I was talking about. The axis of symmetry is halfway between the zeros. The axis of symmetry would be at x equals -b over 2a, which is -6 over 2 times 4, and that's -3/4. And that equals -0.75. And that estimate, I would say, is not directly plausible. Now, everything I said originally is correct except my numbers in the quadratic formula. Just to review where we are. Quadratic formula, y-intercept happens when x equals 0, y equals f of x are the 3 things we need to locate these 3 points. Do the arithmetic correctly in your quadratic formula and you get the coordinates of those 3 points. Then one more principle. Your vertex is on the axis of symmetry. Okay? So to find the vertex, the axis of symmetry is actually the vertical line, x equals -b over 2a. In this case, -0.75 or -3/4. Y coordinate is when y equals f of negative 3/4. Which equals, get the numbers right, 4 times the square of 3/4 plus 6 times 3/4 minus 16 minus 15. 3/4 squared is 9/16, so that's 9/4. 6 times 3/4 is 18/4. And 15. 15 is 60/4. So we can add the numerators. 9 and 18 is 27. If you subtract 60, you get negative 33. Fourths. It's negative 3/4. This is negative. This is negative. So this will be negative. Now we have negative 69 over 4. I knew it couldn't be negative 33 over 4 because 33 divided by 4 is like 8. It's a little more than 8. And I know that the vertex is lower than the y-intercept. Vertex can't be higher than the y-intercept because it's a low point in the graph. Okay, so that's approximately negative, well, it equals negative 17 1/4. Now on the graph, does it make sense? This is just a little bit lower than this, right? If this is at negative 15, does it make sense that this could be about negative 17? Well, yeah. So the vertex is there, and that fits just fine with the calculations, with the graph I got from the calculations I finally corrected, okay? So again, use a quadratic formula to locate the zeros. You plug in 0 to locate the y-intercept, and then you calculate the axis of symmetry, which is just going to be negative 6 over 8. That's negative 3/4. You don't even really need to go find the formula, but it's a good thing to write it out and do that anyway. But that's negative 3/4. Now we estimated negative 1.2. It's actually negative 0.75. So that estimate is kind of not very good, but you know, I'm fudging the shape a little bit, okay? But it's plausible. And the negative 17 is plausible because it has to be lower than the negative 15, but not much lower. Okay? That's the process. And if you know how to do all that, the first pretty tough thing you get in a pre-calculus course is just this. If you know how to do all that, you've got 70% of quadratic functions not. Okay? You have them. You understand how to do the graph. Now there are other things that you're going to do in pre-calculus. We're not doing the whole ball of wax. We're not doing completing the square and stuff. But you'll be in shape to do that. Okay? So there's one thing I urge you to do. It's understand this picture and how to get a picture of the graph of the quadratic function with the zeros if they exist, and the y-intercept and the vertex. One last thing. If you don't have two zeros, you can still graph the thing, because you can always calculate the vertex, whether you get a positive or negative under the square root. The vertex is still going to be at this. So you're going to be able to find the coordinates of the vertex, and then you can use symmetry to draw the graph from just the y-intercept and the vertex. Now this also goes into how you do transformations to graph quadratic function, the vertex form, but we're not going to have time to do that because we need to kind of move on to stay ahead of pre-calculus course. So you're going to have some details to fill in, but this should be very valuable to you.